Let's go ahead and take a look at this just to kind of help guide you with this homework, right? I will also take a picture of this and post this on week 12 because that's where we're at. So that's where you probably found this. I'm going to go ahead. Please make sure you put your name. I'm going to put 2020. We should have went over this on Friday. I was having computer problems and then it was just miserable trying to get the computer up and working. I finally was able to get back into Teams and log in and finally got it working. So next week, if you're watching this over the weekend, next week we will definitely go ahead and just kind of start with this to make sure that everybody's on the same page. If you haven't watched it, then we're going to talk about it in class and you're not listening to this at all then, right? Because you didn't watch it. Let's start off with the top, and I just want to kind of read the directions. It says here, determine the net force. When we see the word net force, we mean the overall amount and direction. Okay, and so be prepared to make sure on quiz and test that you do give the overall amount and direction when you see the word net force for each of the following free body diagrams. Okay. So free body diagram, again, your choice, either draw the picture or draw a box, whichever one makes it a little bit easier for you. You have, for an example over here, let's go ahead and write this as a quick reminder. If vectors, I'm just going to put vectors. Don't forget, if they're in the same direction, we're going to add them. If they're in opposite direction, we're going to subtract them. Just as a quick reminder. Let's go over here. The net force, I can see that one's going up, one is going down. They're in opposite directions. Because of that, I know that I need to subtract. Okay, so let's go ahead and get, again, when we subtract, we do not care about a negative value. So either subtraction and find the difference and don't worry about a negative, or when you're putting it into your calculator, please put the bigger number value in first, then subtract the smaller number. Okay, so 1200 take away 800 equals a magnitude of 400 newtons, and direction of the acceleration is going to be up 400 newtons, or you can write the word up. That's what they're looking for. They're looking for you to do that here, and they're looking for you to do that over here. But remember what I said. If I'm drawing a free body diagram, then I'm always going to have a downward pull, because that's going to be the weight force or gravitational force. And it doesn't matter whether I'm here or on another planet or the moon or a star, because everything has some type of gravitational pull, and that's what this downward arrow is. Now, we can have 2 vector arrows, we can have 3 vector arrows, we can have 4, we can have 7, we can have 8. Okay, there could be many vectors that are being applied to an object all at the same time. What you're going to do here first is, for this last question, you're going to go ahead and first find the vertical. I'm going to put find vertical vector. Why am I going to go with vertical first? Because there's 2 vector arrows. So let's go ahead. They're opposite directions. Let's subtract them and find the vertical vector first. And then second, we're going to go and find the horizontal. Because there's only one, and we don't need to add it or subtract it or anything. Okay, so you'll get an answer over here, but that's how you're going to do vector arrows that have X and Y components. Okay, let's go to next one, number 2. Let's zoom out a little bit. It says here, free body diagrams for 4 situations are shown below. 1, 2, 3, 4. The net forces, or the net force, is known for each situation. Okay, the net force means the overall, what's going to happen, the overall answer of not just magnitude, but also direction. However, the magnitudes of a few of the individual forces are not known. Analyze each situation individually and determine the magnitude of the unknown force. For an example, you're looking for this vector arrow and this vector arrow. Give us an answer. So for the forces for letter A, how much newtons is going to be over here? And for the force on vector B vector arrow, how much value or magnitude is going to go over here is what they're asking from you. Well, I can see that the overall net value or the net force for this free body diagram is 0. What does 0 mean? It means that everything cancels out. Because it's equal and opposite, right? So in that case, if I have 200 newtons pulling down, then I must have 200 newtons pulling up. That way they can cancel out to 0. If I have 50 newtons pulling to the right, then I must have 50 newtons pulling to the left. That way they can cancel out and equal 0. So what is going to be the vector arrow A magnitude? 50. And they gave me the SI unit of newtons. What about B? 200. And you're going to do it for the rest of them, okay? Remember, first thing is you need to look at the overall net vector or the net answer of what's going on. Let's go ahead and go to the next question. Question number 3. Draw a free body diagram. Okay, so you're going to do the drawing of this diagram with arrows only, but no known magnitudes for the following objects. Arrows only, no magnitude, meaning no value, no number amount. Okay, well, we can do that. Let's go ahead and do this one. A ball falling in the presence of air resistance. Well, I'm going to draw the ball. So it's falling, that's a keyword, in the presence of air resistance. So after you draw the object, the next thing that you do for free body diagrams is to draw a dot or a circle in the center. I guess I would say the next question would be to ask yourself, is this situation in equilibrium or it's not in equilibrium? Is it balanced or unbalanced? This is unbalanced because it is falling. So the resultant or the result here is going to be a downward direction. A downward direction. And because it's falling, then that needs to be the larger arrow. It's in the presence of air resistance. And if an object's falling, air resistance is pushing up on it. It's trying to slow it down, but it can't. Air molecules aren't strong enough like a feather to slow it down. I'm not going to put any magnitude with it, but let's go ahead and let's make sure that we label it. F sub G or an F sub W. F sub F. And sometimes you'll see it F and some people put the word air for air resistance. But to me, air resistance is the same thing as friction. They're touching. There's friction being involved. Go ahead and do B and then go ahead and do C. Okay, let's keep going. Turn the page for those of us who want to kind of just start on the homework this weekend. That way you don't have to worry about it much. And then next week you can kind of like double check some of your answers with me or see what if there's any questions. It says over here, let's zoom in a little bit. 4 forces that are acting on a hot air balloon are shown in the diagram over here to the right. Find the net force, which is the overall magnitude and direction, for the horizontal and vertical direction. Okay, well, so now they want you to start off with horizontal and vertical. Again, on quiz or test, they're probably not going to break it down A, B, and C for you. Okay, they may stop right here and say, find the overall net force and be done with it. Meaning that you need to find out what is going to be the overall answer. Give me one arrow with the number, with the correct theta for direction. Now, here's a hot air balloon. They gave me my forces with it. This is 1520, 5120, 950, and 4050. Okay, so let's find horizontally. Horizontally, I'm going to come over here and I'm going to, again, just put the bigger number in first because I'm not looking for a negative value. 1520, take away 950. Hopefully I did not do this math. That's okay. Which, I mean, it's simple subtraction, right? Do it in your head, Miss Munson. 1520 subtract 950 comes out to 550. I'm sorry, 570. Vertically, I'm going to, again, put the bigger number value in first. I do not care about a negative value. 5120 newtons subtract 4050 newtons. All right. So 5120 subtract 4050 equals, and that comes out to 1070. Okay, 1070. So let's go ahead and write our answers over here. Horizontally is 570. Vertically is 1070 newtons. They have the newtons there for us. Now it says here, well, let's go overall and find the magnitude and direction of the net external force acting on this hot air balloon. And don't forget, when you mean magnitude, it means the number for the arrow, and the direction means the theta. Okay, so overall, who is going to win horizontally? Is it going to be to the right or to the left? Which number is bigger? The left. Vertically, which number is bigger? Up. So my overall arrow is going to move to the up and left direction, northwest, right? So let's go ahead and let's do that first. Draw out your arrow in the direction it's going to look. Then you're going to come over here and you're going to put your Y and your X axis. Always at the tail end of your arrow is going to be your theta. Okay, now you found horizontal and vertical. Horizontally, this vector right here is 570. Vertically, this vector right here is 1070. I see that this forms a right angle, and if I go ahead and label it, across from the right angle is always my hypotenuse. The theta and the right angle equals my adjacent. What's left over is my opposite leg. You're going to have to do 2 steps for sure, guarantee you. Okay, step number 1, that's just me. I like to start off and find that theta. So I'm going to SOHCAHTOA. SOHCAHTOA. Okay, now let's see what I was actually given. Let me get my highlighter out. They gave me this leg, and they gave me this leg, which is the A and the O. Who is A and O? The tan. That's why I'm going to use this equation. So the tan of the theta equals the opposite leg over the adjacent leg. This is like your equation right here. Okay, or the tan of the theta, which I do not know what it is, equals 1070 over 570 equals a number. Okay, please go ahead and put that into your calculator. When you're done, though, that is not your answer. It comes out to the tan of the theta equals whatever this number is, right? You're going to put this number down here, but don't forget to find the inverse, which is the opposite. You're going to need to second key tan this, and then you're going to find your correct answer. Okay, step 2, I'm going to put step 2 over here. Some people like to use SOHCAHTOA again, which is perfectly fine. Or I don't mind using Pythagorean because this is your C, your hypotenuse is your C leg. So A squared plus B squared equals C squared. or 5/7d squared plus 10/7d squared equals c squared. And again, don't forget at the end to square root it all, right? So that way you can find just the hypotenuse or just the C leg. What's going to be the SI unit that goes with it? Well, those are in newtons, so this is going to be a newton also. Okay, so please, hopefully this helps you. I'm not saying that this is just easy peasy here, but you do need to practice. I think watching the video is going to help. Watch it again the second time for you to work on this one. Okay, you do have to practice on your own a little bit, so that way you can see what you don't know. When you ask me for help, which is not a problem, when you tell me you just don't know how to do this, I'm going to ask you what part. Okay, some of you are going to get mad. Well, I just don't know. What part don't you know? I cannot help you if you are mad and angry and you just block everything out and I just don't know how to do it. No, you need to stop for a moment, take a breath, and say, okay, Miss Munson, here's where I get confused. I can get to the drawing, and then after that, I get lost or I get stopped, or I do the drawing and I write SOHCAHTOA, and then I'm confused. So please, please, you need to talk to me, but yet you need to tell me where you're lacking. Okay? When you just say, I just don't know any of it, well, you do know some of it. You're just upset, mad, angry, and frustrated, and you need to get that frustration out of the way. Okay? There's a question over here that you need to answer, and then number 7, you're going to use the picture over here, and I'm not sure. Is this the same one? It might be. So make sure you do it. The other thing is people are losing points off of their homework and they're getting upset. That's because they're just giving me the answer. You're just going to give me the answer here and here. I'm not going to give you credit. Okay? You need to show me your work. Alrighty? Making sure. I'll take a picture also and post this. Hopefully it helps out. I'm not sure. Let me know if you still have questions. Alrighty? Have a good weekend.